Hello, my name is Juan Moresco, and this is the first of three videos. So, in this one, I will be covering AWS global infrastructure, how it's organized, and the key service for building global applications like Route 53, CloudFront, Global Accelerator, Outpost, Wavelength, and local zones. So, let's get it. So, why will you build a global application? The idea is to deploy it across multiple geographies using AWS regions and or edge locations. There are three main reasons. First, decreased latency. If your users are in Asia and your server is in the US, the packets take time to travel. Deploying closer to the users means a better experience. Second, the disaster recovery. If an entire AWS region goes down, for example, with an earthquake, storm, or a power outrage, you can fail over to another region and your app keeps running. Third, attack protection. A globally distributed infrastructure is much harder to take down. So, AWS global infrastructure has three core components. First, regions. These are large geographic areas where you deploy your applications. Each region contains multiple availability zones. The second is availability zones. These are physically separate data centers within a region, connected by low latency links. And finally, edge locations, that are also called point of presence. These are the closest point to your end users, used mainly for content delivery, and service like CloudFront and Route 53 rely on them. Route 53 is AWS managed DNS service. It translates domain names into IP addresses. The most common record types are record for IPv4, AAAA for IPv6, CNAME for hostname to hostname, and alias, which points directly to AWS resources like an ELB or CloudFront distribution. The routing policies are what make Route 53 powerful. So this means simple, basic DNS, no health checks, weight, split traffic by percentage, latency, route users to the lowest latency region, and failover for disaster. Then we have CloudFront. This is AWS Content Delivery Network. It catches content at edge locations around the world, improving read performances and user experience. It has hundreds of points of presences globally. It also has built-in DDoS protection through AWS Shield and WAF integration. The origins it can serve from including an S3 bucket using origin access control, a VPC origin for resources in private subnets like ALV or EC2 instances, or any custom HTTP. So to continue, a lot of people confuse these two. First, CloudFront uses the Global Edge Network, catches files for a TTL, typically around a day, and is great for static content that needs to be available everywhere. On the other hand, S3 cross-region replication must be configured per region, files are updated in near real time, and it's read-only. It's ideal for dynamic content that needs low latency in a few specific regions. S3 Transfer Accelerator speed ups uploads and downloads to S3 by sending the file to the nearest edge location first, which then forwards it to AWS private network to the destination bucket. For international transfer, it's significantly faster. AWS Global Accelerator improves your application's availability and performance using the AWS internal network. It creates two Anycast IPs for your application: traffic center through edge locations and travel over AWS private network to your application. up to 60% improvement over the public network. Finally, three more infrastructure service worth knowing. First, Outpost. This is the physical AWS rack installed in your own on-premises data center. You can run EC2, S3, RDS, and more in your facilities using the same exact AWS APIs. Then we have Wavelength. This is AWS embedded in 5G carrier networks, enabling ultra low latencies for use cases like smart cities, AR VR real time gaming, and connected vehicles. Finally, we have local zones. These are extensions of AWS regions placed closer to the end users in specific cities. For example, the US East One region has local zones in Boston,